Hello and welcome to this presentation on the CiteSource R package and Shiny application. My name is Trevor Riley and I'm here on behalf of our development team, including Sarah Young, Lucas Walrick, Caitlin Hare, and Matthew Granger. And today we'll be taking a look at data-driven search strategy development with CiteSource, but we'll only have an opportunity to take a look at a sliver of its functionality. So I would encourage anyone who's interested to take a look at the GitHub page as well as the CiteSource webpage, which provides links to a number of our vignettes that dive deep into various use cases. I'd also like to mention that CiteSource got its start through the Evidence Synthesis Hackathon initiative, so really want to give a big thank you to that group for the support in hosting us and getting our team put together. All right, so let's jump into this first use case. And this one, we're just going to be comparing database coverage. We have taken a simple search string and change the syntax so that we can apply that string to 6 different information sources because we want to compare the overlap, pretending that we are at the onset of an evidence synthesis project and we're trying to understand the potential of these different resources to provide evidence. So the 6 databases or information sources that we searched were Aquatic Sciences and Fisheries Abstract, Dimensions, Oceanic Abstracts, Open Access Theses and Dissertations, Scopus, and Web of Science. When users upload citation files to CiteSource, they can tag each of those files with 3 different strings, metadata for 3 different strings, that is source, label, and string. In these examples, we'll be taking, we only need source and label. So they start off by getting the source name that is equivalent to their file name, but as you can see, you can go in and edit these. So in case you had multiple files from Web of Science, for example, you can combine them so that they are all coming from the same source. And in this case, we've labeled each of them search since they come from the search phase. I'm not going to dive into deduplication, but deduplication comes from the ACES package, which was developed by Caitlin Hare. So she has some really great videos out there. I would recommend taking a look at them. But ACES is going to find duplications automatically, and then it's going to highlight anything that might be a potential match. Here we've already done the automated and manual deduplication, and so really I just want to jump into the visualizations. All right, so let's take a look at this upset plot, which is would be the most important plot to look at when we're analyzing the overlap between these databases. Each of these rows represents one of our databases or sources, and then as you move through the columns, you can actually see the number of records represented by the bar, and which databases included the overlap there. So for this first column, you can see there are 44 records between these 5 databases or 5 information sources that overlapped. Then you can see, and this makes a lot of sense, right? These 3 databases or information sources, Web of Science, Scopus, and Dimensions, right? These are very broad information sources, contained the highest number of overlapping sources. Following the columns all the way down, this is where we can start to see the number of unique records that came from each source. And if you follow each of these databases over, you can see the count. But in this case, right, we see Oceanic Abstracts didn't provide any unique records, and that's because Oceanic Abstracts is actually one of the databases that is included within Aquatic Sciences and Fisheries Abstract. So while this is, example data, it is a great example of when trying to analyze what databases have the potential to provide the most impact. You can start to see how much overlap there is between each one and make a decision based on some of this data. What's great about the Shiny application is if you wanted to see what the overlap would be without oceanic abstracts, for example, you can just remove it using this left-hand filter, and then we have a new plot. So let's jump into our next use case. And this one, we're actually going to be comparing two different search strings. So in this case, we're going to upload a number of different citation files from three different information sources, but using two different search strings. We're also going to include some benchmarking articles. So if you take a look at this, we have 20 benchmarking articles. And then, again, this is to compare search strings, not necessarily coverage, but it's of databases. But we're going to take a look at dimensions, Scopus, and Web of Science. And we've applied one search string to all three, and a second search string to all three databases. In this case, we have kept the source name for each of these. We have dim1, dim2, Scopus1, Scopus2 again, and then applied the label of search. Then we can move on to deduplication. So we run automated deduplication, and then we can select any extra additional duplicates to remove manually. Again, we're not going to run through this due to time. Once we select those, we can move on to our visualizations again. All right, so again, let's take a look at this upset plot, and I'm going to make this just a little bit larger. Looking at the plot, we really want to focus on our benchmarking articles, because this is how we're going to be comparing, which of these search strings did a better job at catching our benchmarking articles. So looking at this first column, we can see that across all three databases, both strings caught 10 of our benchmarking articles. But as we follow the columns over, we see this one here, right? This one marked with three benchmarking articles were caught using the second string in Web of Science, the second string in Scopus, and the second string in Dimensions. And so if we were comparing variations of search strings, and right, it doesn't need to be 2 different strings, right? It could be 6 different strings, and we could just test it against Web of Science or Scopus or Dimensions, right? So you can have multiple variations of a string, which really speeds up the process of testing and validating our searches. You can see, right, this string just performed better. You can also see, right, Dimensions and Web of Science caught 2 articles that Scopus did not. And then you can see that, let's see, Scopus here caught 2 articles that Web of Science and Dimensions did not. Finally, if you come over here to the end, you can see that there are 2 benchmarking articles that were not caught using either string in all 3 of our information sources that we searched. And then you can use the interactive record table to take a look at the different records from the databases and information sources you search. So, for example, if you had a really high number of records that came from one resource, you may take a look at those citations, jump in and read, quickly look at their abstracts, because these link directly to the record of publication. And then you might find, there was something wrong with your search string if you look back at it. And then you can also take a look, right, at these benchmarking articles, so you can see, why did we miss these articles, and you can link directly to them from within CiteSource, and that'll just open up in a new tab within your browser. All of this information, all the data, you can export it as well in either CSV or RIS. And when you come back to CiteSource later, instead of uploading the initial raw sources and going through the deduplication phases again, what you can do is you can just upload that RIS or CSV, and it's going to provide you with all those visualizations and tables again. But now I want to show you one last use case and another visual here. All right, so in this use case, what we have done is we have uploaded a number of RIS files. Let's walk through these. So we have that second string, which we applied in dimensions. We also have that second string, which we applied in Scopus and Web of Science. So we've seen the data on that before against those benchmarking articles. But what we've added here is we've done some citation searching. So we've actually looked at the citations of a couple of papers and the references of those same papers. And we've brought in the RIS files for those. We have also done a hypothetical call for papers to experts. And then we've uploaded both the title and abstract, the files after title and abstract screening, and the files included after final synthesis. So in this use case, we're really looking retrospectively after we've finished an entire synthesis to really understand the impact of each of our sources and methods, right? Because when we upload these, right, they're not just information sources like databases and platforms anymore, but they're actually different methods like citation chasing and a call for papers. So in this case, what we're going to do is we're going to remove these tags within this source because the final and title and abstract files didn't really have a source, and instead we're going to label them with final and screened. So CiteSource takes either search, final, or screened within label. Those are the three custom metadata that you can use, and we're going to go ahead and go through the deduplication process on these. So we're going to run the automated deduplication process. Again, this is using the ASYS package. And then we're going to go over the manual deduplication again, just like before. We're going to remove those duplicates. In this case, I know these ones are duplicates, and we're going to remove those and go straight into the visualization. All right, so here we have the heat map. I haven't shown this in these use cases. It's a great way, though, to see the duplication and overlap between individual databases and methods. And then we have our upset plot. Again, we've reviewed this in the other use cases. But what this use case, what's really great is taking a look at this phase analysis plot. And in this case, we can see the number of unique sources, which are in green, and the number of duplicate sources, which is in red, for each of our different sources of information, whether it be a method or an information source like a database. So we have dimensions, our call for papers. This is our citation searching, both in the citations of the papers that we looked at and also the references of the papers that we looked at. Scopus and Web of Science. And so you can see the number of unique and duplicate articles at the initial search phase, right? And then after title and abstract screening, and then finally the articles that were included in the final synthesis. So in this hypothetical example, we can see that the call for papers was extremely fruitful because it, of the 16 papers that were included, from the paper call, 13 of those were unique. And another really neat thing about CiteSource is if I were to go back here and I really didn't care too much about differentiating the citation searching. Oh, this is the paper call. If I wanted to make these, oh gosh, there we go. Considered the same source, I could just rerun this data. So I'd go back, I would change the source, I could go to the automated deduplication again, and so again, that's going to just rerun everything together, and we go over to the manual deduplication. I can remove our extra duplicates. And when I go over to the visualization, I can see that it has combined all of those forward citation searches and backward citation searches into one. And so if you started with, 5 different RIS files for Web of Science, for example, you can just upload all of those and just say, hey, these are all from Web of Science. Okay, and now into the tables, I want to show you the precision and sensitivity table. So this is a really great way to see, the calculated precision and sensitivity of each of the information sources. So much of CiteSource's, functionality has, a history in other people's work. So in this case, Alison Pathel's search summary tables is a great example as to where CiteSource got some of its inspiration, and really looking at the precision of not only information sources, but you can imagine, right? You can, if these are, you could break this down into individual searches. So if you did apply multiple searches to databases, you could see the precision of each individual search. So really so much data here to explore and so many other use cases to explore. So I know this has been just a really quick introduction to CiteSource and some of its functionality, but if you're, I hope that you join us in reporting some of this data in your in your work, and also working to validate your searches using CiteSource, and learn more about the impact of the sources and the methods that you use within your synthesis, so that the entire community can learn. And I really see the opening up of this data as something to be really really important in reporting synthesis and creating a more transparent body of work of the community. So thank you again. And again, if you have any questions or want to learn more, please check out the CiteSource website. And thank you so much.